All right, this is lesson 6.2. This is the second video. And so we completed our first video. We did the linear equations. And now we're back. We've got a quadratic equation. A quadratic equation, hopefully you remember. That's when there's a second power in here. Oh, look, there's an x squared. There's a couple variations on this, so I want to make these clear. So we'll do one type of each, and you might think, oh, these are easy. But there's certain ones I would say are not so easy, so it's worth reviewing all of them. Okay, the first type of quadratic is when you have an x squared, but you don't have an x to the first power. It's just an x squared. Because if you look at the next slide, there's going to be an x squared. And look, there's also a 7x. There's an x to the first power. So you treat those differently. When it's just an x squared, what do? It's just like a linear equation. I'm going to subtract 5 from both sides. So I get the variable by itself, and I get x squared equals negative 4. And right now for trigonometry, we're using only real numbers. So you would look at this and say, how do you square a number and get negative 4? For real numbers, that's impossible. You can't do that. And so this one does not have an answer. It has, plus 2i and minus 2i. But for real numbers, there's no solution. But the point to make in this problem is, when there's an x squared, and there's no x to the first power in here, it goes straight to the plus 5, get the squared on one side, get the number on the other side. All right. Let's try that with a trig one. This is problem number 3 here. We did those two already. Here's number 3. So look at this. We have 4 sine squared of x minus 3 equals 0. So notice we have a sine squared, but we don't have a sine of x to the first power. That's not in there. So this is a quadratic, but it doesn't have that linear term. So our strategy is going to be get the sine squared by itself. So 4 sine squared of x, I'll add on the 3. I'll put that over here. I'll divide by 4. So sine squared of x equals 3/4. And at this point, you know how to get rid of a square. You take the square root. So I take the square root of both sides. Here I get sine of x. Here I put in the plus or minus. The square root of 3 I don't know, so I leave it square root of 3. The square root of 4 I know, it's 2. So I get the sine of x is plus or minus the square root of 3 over 2. All right, you may know that off the top of your head. If you do, good for you. If not, let's look at that unit circle. Sine was the y-coordinate. Get this other stuff off here. And I'm looking for square root of 3 over 2, except they gave me plus or minus. So think about that. Sine is the y-coordinate, square root of 3 over 2, square root of 3 over 2. But these minus ones are okay also. Look down here and down here. So square root of 3 over 2 plus or minus, look at that. There's 4 answers. Pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds. Look at all those answers for this problem. So we got that one there and that one there. And that's it. I take those answers back. Those are my solutions. So back that up, a couple more. And that's it. I am done. So sine x equals plus or minus square root of 3 over 2. So x could equal pi thirds, or it could be 2 pi thirds. Those are when the sign was positive. Where is it negative? 4 pi thirds and 5 pi thirds. And again, right now we're just learning these things. You're using your unit circle as a reference. Ideally, we'll get to the point where you can just do these in your head. You don't even need your unit circle. All right. Let's go back up and try another quadratic. So come back. Let's just first do it algebraically. Oops, I skipped. And let's do this one. And now notice in this one, we have that x squared. But look at that. We got that green arrow. We got that 7x in there also. So how do you solve these quadratics? Well, step 1 is set it equal to 0. So I go x squared plus 7x. I'll subtract 11 from both sides. 3 minus 11 is a negative 8. Equals 0. And in this case, so quadratic is different than linear. Linear, you got your variable on one side, number on the other side. Don't do that with quadratics. Quadratics, set them equal to 0. At least quadratics that have this linear term in there. And now, how do you solve this? Well, I would highly recommend step 1 is try to factor. You could always use your quadratic formula, but I think if I could factor, I would try that first. So let's factor this. And our strategy was sometimes you'd write it like this or something. Maybe put like your negative 8 here, really something like that. I guess I always just like to break it up and say, okay, I've got a negative 8 what times what is negative 8? And there's all sorts of possibilities. How about negative 1 times 8, negative 2 times 4, negative 4 times 2, and negative 8 times 1. You're always using integers here. But which one, when I add it up, gives me this 7? And it's that one right there. And so this is going to factor into x minus 1 and x plus 8. If you forgot that, you can always break up that 7x into the minus 1x plus 8x minus 8. And where did that come from? It came from this part over here, a minus 1 and a plus 8. Then you group the first two and you group the last two. Hopefully this is bringing back fond memories. So x times x minus 1, I pulled out a GCF of x. The second two have a GCF of 8. Now look, they have an x minus 1 in common. So I get x minus 1 times x plus 8 equals 0. Then I use something called the zero product property, because look, I'm multiplying two things and I'm getting 0. How could you multiply two things and get 0? Well, one of those two things has to be 0. So x minus 1 equals 0, meaning x equals 1, or x plus 8 equals 0, meaning x equals negative 8. So a really good algebra review going on here. Okay, let's try this with a trig quadratic equation. I bet you are just thrilled. Not easy stuff. All right, let's try this one. First of all, you notice it's quadratic. I just want to peek at one thing. We'll come right back. Okay. You notice it's quadratic. It's sine squared. But they've got that linear term in here. So we want to somehow factor this. I notice I've got a 1. So how do you break up a 1? Well, how about 1 times 1 or negative 1 times negative 1? That's about all we've got. And the 1 times 1 is my choice because that adds up to 2, and I have that 2 right there. So I can break this up, or knowing it's 1 and 1, I know this is going to factor into the sine of x plus 1 times the sine of x plus 1, and it equals 0. Well, wait, how can this equal 0? Either the first term equals 0, or the second term, which happens to be identical, so I don't really need to do this twice, but I'll just write it, or the second term equals 0. Now look, these are linear. Get your sine by itself, take off the 1, so the sine of x equals negative 1, and again, I'm going to stop doing it on the right side because it's the same problem. No need to do it twice. So where does the sine equal negative 1? Use your unit circle. Sine is the y-coordinate. You know what that is? Let's peek at the unit circle and see. Where's your y-coordinate negative 1? We're expecting two answers. But look at this. Negative 1. I only see my y-coordinate negative 1 at one single spot there, at 3 pi halves. So we come back here. What's our answer? X equals 3 pi halves. Done. Okay, start the problem. We had a square. When it's a trig function squared, we could have gotten up to 4 answers. But look, we factored it. We got the same thing twice. That cut our answers in half, so now we're down to 2 answers. When the sign is 1 or negative 1, that's at the top of the unit circle, at the bottom of the unit circle. It only happens once. So in this problem, we only got 1 answer. All right, let's look at the next question. This shows up in the homework, and it just really throws people. And so I want to point this out to you now so you won't be the person that gets thrown by this. Okay, cosine x minus a half times cosine of x plus root 2 over 2 equals 0. Guys, it's already factored. This is an easier version. You have this times this equals 0. You can go right to work. Cosine x minus a half, that's 0. Or cosine of x plus root 2 over 2, that equals 0. Solve this. Cosine of x is a half, or the cosine of x is negative square root of 2 over 2. So when you already have it factored and it equals 0, if it equals something else, you've got a mess on your hands. But when it equals 0, this is easy. So I want to look, cosine is my x-coordinate. Where's it a half? And where's it negative square root of 2 over 2? I'll show you on the unit circle. But maybe try this one without. Where's your cosine a half? Cosine is the x-coordinate. Are you thinking pi thirds? And are you thinking also in the fourth quadrant? Where else is the x-coordinate a half? at 5 pi thirds. And where's the cosine negative? Are you thinking the second and third quadrants? Are you thinking 3 pi fourths and 5 pi fourths? So if you can do this without your unit circle, even better. If you want to take a peek and look at your unit circle, that's okay too, because like I said, we're just learning this. So that completes our second video with the quadratics.